So we're going to have a look at another one of these models, and we're going to have a play with it. So a company has $1 million to invest. It decides on a financial institution that promises that the value will grow according to this equation, where A0 is the initial amount invested, T is the number of years since the money was first invested, and A of T is the value of the investment at time T. So determine the value of the investment after 4.5 years to the nearest dollar. Alrighty. So we know that A0 is the amount being invested. That's $1 million. And we find out that T is 4.5. And just double check, right? $1 million to invest. That's the amount invested. And that T is the number of years since the money was invested. So T does indeed equal 4.5 years. So into the formula we get A of 4.5 is equal to 1 million times e to the 0.0488 times 4.5. And in our calculators, we can work out this is approximately going to equal, it equals 1,245,578 cents. Actually appears to round there, so it's actually strict equals. Alrighty. So after 4.5 years, they'll have made $1,245,578.40, or $245,000 approximately dollars more than they started with. Alrighty, so let's have a look at part B. How long must the company maintain the investment to the nearest month if they want a 50% increase in the value of their investment? So, since we're looking at $1 million to start off with, a 50% increase would be $1 million times by a growth rate of 100, well, plus 100 plus 0.5, or 1.5, multiplier of 1.5. In this case, it's 1,500,000 Alrighty, so we're waiting until A is equal to that, or in this case, when A of T is equal to that. Alrighty, so using the formula, we get 1,500,000 is equal to 1 million times e to the 0.0488 times 4.5, times T. And we're looking for T in this case. So the first thing is we're going to do, divide both sides by $1 million. Simple multiplication, these will just cancel. And most of the zeros on the left-hand side will cancel, and we'll be left with 15 over 10, or 1.5, is equal to e to the 0.0488 t. Natural log of both sides. And where these cancel, so we just let ln 1.5 is equal to 0.0488 t. Divide both sides by 0.488. And we're left with t is equal to ln of 1.5 over 0.0488. And this is approximately equal to 8.3087 years. Which is fine, and if we were asking for years, then we'd just round this straight up to 9 years, because at 8 years it wouldn't be big enough. But we need to convert this into years and months, so we've got 8 years and 0.3087 years. But if we times that by 12, that's going to tell us how many months we'd have. So 8 years and how many months? And we get 3.6 7 months, but I'm going to round that up to the nearest month, so that would be 8 years and 4 months. So therefore it'll take 8 years and 4 months for the account to grow to 50%, or 1 million, or 1.5 million. Alrighty, I'll see you in the next one. Goodbye.